Hello, good afternoon, everyone, and welcome to the 11th R&D session powered by EDP New. I'm Alexander Neto, and I will be your host today, and with the help from Eduardo Rodrigues, my colleague, and some distinguished guests. Today's session, as you know, it's will be focused on batteries. This is our 11th session, and as maybe you've participated in before, we have discussed a lot of subjects, presented EDP news projects and our team. So these sessions are also available on our website. So feel free to check them. But without any further ado, we have today a session about batteries with some guests. I will give the floor to my colleague Eduardo Rodrigues, who will be moderating the session. I hope you enjoy it, and go ahead, Eduardo.
Thank you, Alex, and hello everybody, and welcome once again. Thank you for attending another R&D session. This is our 11th session, and what brings us here today are batteries. I am Eduardo Rodrigues. I work at EDP New, and I will introduce you to this topic. Today we will also have the participation of 3 key speakers, and later you will be able to question them as well. The ongoing energy transition entails several changes required to properly address many technical and business challenges and smooth the way towards the full decarbonization of the European economy. In this context, different technologies became particularly relevant to tackle most of the barriers faced when undertaking the desirable transformation to achieve a renewables-based electrical power and energy system. Energy storage is now considered the 4th system element and plays a relevant role supporting generation, transmission, and distribution. The capacity to efficiently and safely store energy adds a specific complementarity to account for when planning and operating power systems. Battery energy storage technologies made energy storage decentralization possible and are now suitable for residential and industrial, grid-scale, and off-grid applications, either supporting the integration of other technologies such as renewable energy sources and electric mobility, or contributing to stabilize and balance power grids. But what are the barriers to overcome and the opportunities to explore while further developing these technologies? What are the services to provide and their linked benefits? And who are the stakeholders to involve? In today's session, we will try to answer some of these questions as the vision of experts in the field will help us unfold the present and the future of the European battery energy storage industry. Recently, a regulation project was proposed to the European Parliament and Council, aiming to modernize the European Union's legislative framework for batteries. On the explanatory memorandum, battery development and production were pointed as strategic imperatives for Europe in the context of the clean energy transition underway. The World Economic Forum estimates that to accelerate the transition to a low carbon economy, it is necessary to scale up the global battery production by a factor of 19. Technology advancements, social needs, and market demand are rapidly making batteries an attractive solution to decarbonize the different sectors. Regardless of the technology, research is now directed to reduce the costs and improve systems life cycle and batteries power and energy densities. So this was just a brief overview of some of the topics to discuss, but now let me introduce you our guests. They are experts in battery energy storage systems, and they will be providing us their perspectives on the progress and fundamental challenges this sector and its industry are facing. I would like to present you our first guest, Mário Simões from EDP Inovação. Welcome, Mário, and nice to have you with us. Mario is a technology expert in energy storage at EDP Inovação. His background is electrical engineering, and he holds a PhD in electrochemistry and material science. Mario started his career in the industry, and between 2006 and 2008 worked in the energy sector for the Veolia Group in Portugal after graduating in electrical engineering. In 2011, he obtained his PhD degree in chemistry by the University of Poitiers in France, working in electrocatalysis for low-temperature fuel cells. Since then, he participated in innovation projects in Portugal and in Switzerland, having 5 years field experience in lithium-ion batteries, working in R&D at the ETH Zurich and Belenos Clean Power, Swatch Group spin-off. He then joined the energy storage team at EDP Inovação in 2016. Our second guest is Ismael Miranda from EFASEC. Welcome, Ismael, and thank you for joining us today.
Thank you.
Ismael is an energy storage business development manager at EFASEC. He's also the vice president of the Vasco da Gama Collab on energy storage. His background is electrical engineering, and he holds a PhD in electrical and computers engineering. He's currently the manager of the Digital Energy Hub at EFASEC, dealing with microgrids and their optimal energy management. He holds a PhD in electrical and computers engineering from the Faculty of Engineering of the University of Porto, focused on the integration of battery storage in distribution networks of interconnected and islanded power systems. Ismael is with EFASEC since 2012, where he has research on smart grids, coordinated the company's participation in national and European R&D initiatives, and more recently led the R&D department of the Energy Storage Division. Our third guest today is Johan Soderboom from InnoEnergy. Johan, welcome. It's a pleasure. Johan is a thematic leader for smart grids and energy storage at InnoEnergy. His background is physics engineering. Johan has been active in the energy sector for 25 years, mainly working in R&D for the electrical power and energy system. Between 1995 and 2014, Johan worked at the Vattenfall AB in various positions at the R&D department. From 2014 to 2019, Johan was adding a section at the Research Institute of Sweden, where he was responsible for electrical and optical measurement technologies. He now holds the position of thematic leader for smart grids and energy storage in InnoEnergy. And now let's open the session and start with a discussion. Different battery technologies based on lead, lithium, nickel, and sodium, for example, have been developed and brought to maturity and are now fit to a wide range of applications. At every level of the grid, from generation to transmission, distribution to consumption, battery energy storage can deliver important services. Mario, can you provide us an overview of the most relevant application scenarios EDP is focused on, and how EDP's innovation strategy is fostering battery energy storage systems from an early stage? From an end user perspective, considering the current technology maturity, what is more relevant to follow up? The batteries technology itself, power electronic interfaces, systems high-level control, and life cycle management? What is your view?
Hi, Eduardo. Hi, Alexandre, and the other guests. And thank you for the invitation, first of all. And I hope we can have a very interesting discussion between us and for all the attendees. Thanks for the question. Basically, EDP as a vertically integrated company, for sure we will find applications throughout the whole value chain, right? From renewable integrations, or let's say in front of the meter applications, to behind the meter. So, and at this moment, EDP Renewables is actually taking this the biggest wave inside the EDP group, with the projects, the biggest projects they are having in the US, with lithium-ion battery-based projects. Let's say like this. However, in the past, we have had other business units from many geographies also doing projects and R&D and investigation projects in batteries. And you are also very aware of it. You have done also a good job there. So, I mean, the past we have been working in trying to learn the most we can to prepare the future, and now energy storage is actually for the grid is actually taking off, right? And at EDP Innovation, we are actually positioned in a way to support the entire group. And we are, regarding energy storage, we are looking at opportunities both in hardware and software side. So looking in hardware regarding technologies for short-term and long-term applications. Just to say that regarding long-term storage in our group, we have a lot of pump hydro, so we are very well equipped in other technology than batteries. But batteries, it's true, it's now they are getting very mature and more interesting subject, because also their cost is going down very dramatically in the past years. So new opportunities come for companies like ours. So I would also like to say the role of EDP Innovation also in this field, and also the collaborations we are having with you in the past, and also with other business units such as EDP Comercial for the retail. That EDP Ventures, for example, recently invested in a company that actually provides batteries for B2B markets, a US-based company called Yotta Energy. So basically, we are trying to cover the whole scope of storage with what EDP covers as a company. Just regarding technologies, as you were asking, also what we do see as the most promising and growing, challenging. The challenges that we will have in this field. I mean, for sure, batteries have been around for many years, and now the whole interest around lithium-ion is probably driven by mobility, right? It started all with it all started with portable devices. Then now the electrification of mobility is creating a huge demand for lithium-ion batteries and driving the costs down. For us, the grid, we are actually benefiting from that, and having also some of these devices that will provide services for us. As you also mentioned in the beginning, Ismael is the vice president of Vasco da Gama Collab, where EDP Innovation is also engaged, and we are actually collaborating and starting this collaboration with another technology that is not lithium-ion, it's redox flow batteries, and also supercaps. Those are the two technologies that the Collab is mostly focusing. So we are not only talking about lithium-ion batteries in this discussion. It's a very open field with many technologies that will evolve in the next years. Just to finalize my first comments in terms of the opportunities, for sure for us, for EDP, where there is always also a big area of interest is how to explore then these assets that are connected to the grid. Many opportunities will come to stabilize the grid, to do time shift, to do energy price arbitrage, and for sure there is a very open field for development regarding how to do this in a very an optimized way for us, and for providing the good service and also the most economic benefit for those that are participating in the markets. That's for sure a big challenge, while promoting the increased life cycle of those assets, because typically we're looking for assets for the grid that last 20 years or more, and lithium-ion batteries are, let's say, in this first phase, not capable of lasting so long. So the whole software that controls these systems and provides us the grid systems and looks at the life cycle of the batteries is also very important.
Thank you, Mario. Well, as you said, battery energy storage is a valuable complement for not only but also for grid applications, either supporting flexible and hybrid power plants better adapt to the energy market needs, grid contingencies and prograde deferrals, also providing key ancillary services during black starts and frequency containments. Ismael, FASEC is focused on developing and delivering integrated battery energy storage solutions to address these challenges. Which are the most significant characteristics to account for in terms of performance to achieve competitive solutions fit to these use cases? And how is the industry progressing on the required developments to leverage these integrated solutions?
Eduardo, thank you for the question. Good afternoon, you all. First of all, to address your question, I think that the performance and what we look, it depends in each application. But what I can say is that from FASEC's perspective, as we don't manufacture batteries, we integrate, so we are system integrators, and we have to, and we look at this from that perspective, meaning that of course for each application we need to choose properly the adequate technology with the adequate characteristics for us to be able to provide the performance that the client wants. But looking at this from a higher perspective, higher level perspective, I would say that what we need to ensure in terms of system integration is that for a given application, we need to ensure that our designs and our sizing of the power and energy is right, so that we can, and we are sure that we can in fact provide a system that can be to the point of the application, both in terms of the capacity, but the capacity in terms of the life cycle perspective as well. We need to, and as Mario was pointing out, this is more and more important. So to adequately manage the system, because this has impact on the actual performance, the benefits that the owner of the asset can gain, and also for how long they can achieve that. So from our perspective, there is a very important focus and a lot of work to be done in software and optimization, and bringing AI through energy storage in order to optimize the operation of the system. We need, at the same time that we think on this and leverage these to enable our systems to provide and aggregate different services, we need to provide solutions that are easy to install, that present lower costs, and one very important point is safety. So the industry has faced problems in the past about safety in energy storage systems. So this is a must, and one thing that the industry needs to look, even when increasing or trying to increase the performance of the system, the overall performance. It's always one thing that we need to look at. To give you a perspective on the progress that the industry is making in, let's say, in several parts, from the batteries to the power electronics and the control and management of these systems, I would say that I don't like very much to compare with what happened in the solar industry, for instance, but what we are seeing now is batteries for utility scale systems to have higher DC voltages, with being integrated in the grid with power electronics of more and more power capacity, with also perspectives, for instance, on PV plus storage projects, on having power conversion systems interfacing both the PV and the storage system, so with DC coupling. So these are parts of the industry that we are seeing evolving more and more, and this is one of our let's say focus in our development. In terms of control and management, as I told before, I think this is a very important or one of the most important factors, because at the end of the day, the energy storage system will only provide to you what your software and management software is capable of providing. So this is a crucial feature, and I would say that is one of the most differentiating aspects in the perspective of a system integrator. I would say that, and just to complement, and as Mario already talked about the Vasco da Gama Collab, one of our perspectives on this is, of course, today's market is focused, and because of the mobility and etc., it's focused on lithium-ion batteries. So, for instance, in 2020, it was like from the battery energy storage was like 98% of the capacity was from lithium-ion batteries, and of course from different, let's say, chemistries, NMC or LFP, more and more for stationary applications. But what we believe as well is that the future will be more diverse, so there will be space for different technologies more and more, even from utility applications to customer side applications, from industrial and commercial applications. And this is something that we want to be also on the forefront of the technology, and that's why we have been looking for other technologies. And in Vasco da Gama Collab particularly, we focus on redox flow batteries and supercaps, with also one of the pillars of the collab is also on the power electronics that can be very specific for different types of storage technologies, and also on energy management system, because again, this will be more and more important as we go for energy communities, for more integration of renewables, for microgrids. I think that is the way the industry is going. Thank you.
Okay, thank you, Ismael. Well, despite the recognized potential and the recent technological progress achieved, Europe still doesn't have a common regulatory approach to energy storage. Does unintended market and legislative barriers are hindering the potential of energy storage based on batteries? Johan, can you please help us understand some of the key barriers to battery energy storage at European level and how to overcome them?
Absolutely, and thank you very much for inviting me to this. I just wanted to comment a little bit on Mario's and Ismael's comments there before to their question. I'm working for InnoEnergy, and InnoEnergy can be regarded as one very big investor in new energy technology, and not the least batteries in that respect. And talking about what we see on the market as upcoming ventures today, I think we also should recognize that there are quite a lot of newcomers on the markets that's looking at new financial models for batteries, and also new business models. And I think this is also an area that is growing quite extensively. It's not just on the pure technology side, even though there's quite a lot of them as well. So I think that is actually a very, very interesting part of the whole infra or the ecosystem when it comes to batteries and battery storage. So, but getting back to the key barriers and not having a common regulatory approach. Unfortunately, or perhaps fortunately, there is a common regulatory approach to batteries in at least on the grid side. And the general thinking there, and general that was actually launched in the third energy package, is that the grid owners, the DSOs, the operators, are not there actually allowed to operate or own batteries and operate them themselves. There are some deviations from that, of course, but that's the general approach to it. So from that perspective, it's we don't. That's of course in Europe one of the big hindrance in that. If you see it as that might also be the correct way to go if we look at it as a purely unbundled market, which I think we should. Then you have, if on the other hand you would, in the areas where you are allowed to have to use well, let's put it like that. Batteries could be, of course, a very, very good component to balance the grid in some way. That's definitely, everybody's agree on that. And one way of doing this, of course, would be for someone else providing a service to a DSO in order to provide this balancing capacity. But there are some hindrance and some regulatory barriers as well on that side, because generally you have a cost plus regulation for how to push the cost onto your customers, and that is generally mostly based on the investment and capex. And if you have a service instead, that's in most countries much harder to include in the cost base for your tariffs. So that's also something that is hindering that type of service offered to the customers. But that's on the grid side, the pure DSO side. But if we look at the other parts of the energy system, electrical energy system, there's really lots of openings for actually on the generation side, as we heard before, to use batteries in order to, for example, extend the functionality of a PPA that you agree with someone, and we can foresee that the operators of renewables need to be much more flexible when it comes to actually act on the energy markets in the future, which also opens up for battery storage. So these are areas where we definitely will be able to see something, and there's no really regulatory hindrance in most markets to actually deploy batteries in that way. On the other hand, there's not that much subsidies either that we perhaps see in other parts of the world that is really promoting batteries in the grid. So I think that looking at the near future, where we will have a retake on the regulations on European base, I suspect that we will continue with a situation where the grid owners, the DSOs, will not be able to own batteries in that respect. However, I think we will see services provided to the DSOs from third parties, which opens for batteries in the grid. So.
Yeah, indeed. Thank you, Johan. Mario, is EDP also looking into associated business models required to efficiently explore these type of assets, increasing the sustainability of the investments and ensuring economic feasibility throughout its entire life cycle? There must be new business use cases emerging already, targeting marketable services to be further explored and valued.
Yeah, the simple answer is yes. But I would just like to add that a bit of history is that the maturity of energy storage markets has been with batteries have been geographically very uneven in the past. So it has evolved, sometimes dramatically. And for example, at the moment, in the US, you have some states that are effectively promoting battery storage with clear mandates and clear goals. And for that, for example, EDP Renewables is addressing it very effectively. Europe is somehow being a little bit lagging behind, but with all the renewable deployments that are coming in, the decommissioning of conventional generation, the increased demand for battery storage is also happening. And we also expect from what the literature says, and if nobody has a crystal ball, but with the deployment of new renewables, new deployment of batteries will also happen, or deployment of more storage will also happen. And with that, batteries are capable of providing very different grid services, right? And intelligence, and also Ismail was speaking before, mentioning before, intelligence for exploring those revenue streams is very important. But when one is designing a system in the first place, you need to have a certain vision about what the revenue streams will be, and in order for it to be bankable. And we know that during the lifetime of a project, of a battery project system, probably there will be new revenue streams coming in, others probably fading away, and it's a very hard field in order to design a project nowadays, especially because battery projects are typically very fast-paced. So the time to market is very, very fast compared to what other technologies were in the past. To solve a problem, you can have a system in the field in a matter of months. And the revenue streams probably will also evolve during time. With that, the life cycle of the whole project will also evolve. So it's a very dynamic field, and at EDP we are looking at it. We have already some experience from projects from the field, but this is also something that will come with experience. So you need to be actually working on the field to understand what are the new challenges and the problems to solve. Regarding also these new business models and stacking of use cases for actually getting revenue streams, you are also very involved in regarding VPPs, for example. So there are many ideas in order to put these devices working together. But one message that I would like to stress is we will not have a crystal ball, and we will not foresee for 15, 20 years how the markets will be. It's clear that they are evolving and changing quite fast. These systems are capable of providing answers in a very short term. And we also need to be adapting and looking at these topics. Just to have a practical example of something that we are doing at EDP, together, EDP Innovation also started with CNET, with New some years ago, involving in this project, and with EDP Comercial, is actually in developing a solution for stacking different revenue streams for batteries behind the meter. So this is a practical example of something that we have been doing internal at EDP. We are also doing other approaches for other types of markets, but it's clearly something very important, is to try to address and collect the maximum of the value stream that we can to actually make a storage project bankable.
Thank you, Marty. Batteries development and production are strategic in the context of the European clean energy transition. But also the decarbonization of other fossil-dependent sectors is also on the move. And whenever this progress involves electrification, energy storage solutions must be considered. Ismail, FASEC is also focused on other businesses, such as electric mobility, where, for instance, battery technologies impact both propulsion and charging solutions. What are the most prominent challenges to tackle when further developing charging infrastructures that must be able to answer to the automotive industry needs, but at the same time comply with the requirements for smooth grid integration? What is FASEC's perspective, and how is its R&D strategy aligned with the technical problems to solve?
Thank you. I would say that electrification is nearly one of the main challenges of the energy sector, particularly EV adoption will pose many challenges, but even more challenges in the future as this adoption increases, both because it will increase energy demand, but also because if we are not careful when integrating these charging stations, it can cause other
Ismail, sorry, can you hear us? I think we are not hearing you properly. We are facing some difficulties with your audio. Not sure, maybe if you can turn off your camera.
I will try.
Yeah, well.
It's better now.
No, we can't hear you at all. Sorry. Maybe we can continue with another question just to check if yeah, really bad audio from your side. We will continue with some other questions just to gain some time to check if we can solve your issue. Okay. This question was related with some of the business FASEC is involved. Not sure if Mario or Johan want to comment on that. If not, I guess we can continue with the other questions. Well, Johan, obviously to maximize the potential of the innovation supported and achieve a highly competitive industry, battery energy storage need to be commercially viable in all its dimensions. Who are the stakeholders within the value chain and the newcomers to expect or attract, and which sectors will be most impacted and will benefit from battery energy storage technical and commercial developments in the years to come?
Yes, thank you for that question. It's an interesting topic, of course. And I mean, if we look at it a little bit from the, I almost said historical, but it's not really, because things are going quickly here. So, but I mean, what we have seen initially is batteries being used behind the meters, and that has been the first deployment of it. In that respect, I think we will continue to see quite a lot of development in that sector. And we see that, I mean, there are some actors that are quite dominant on that side. And we have some of the markets also as well that have had subsidies and so on that really has taken off, and not the least Germany in this case. So, but what we see there now, again, I'm counting from my side, looking at what type of newcomers on the market is turning up, and we see that for one thing, there's new, more I would say inventive business models coming up, where the end customer is really cost neutral for them, where they are using the batteries, perhaps also in combination with the PV in the installation to actually pay for the capex that the end customer has. So essentially, these companies are borrowing the space both on the roof as well as in the basement for batteries, and providing different type of services out to the market. And this is where you're starting to get this new type of aggregators that can actually provide some type of ancillary service, for example, on the market, if it's not just energy trading. So it's also interesting to see if you look at the supply side from this perspective, because if you have taken a look lately on the number of new gigafactory projects that are on planned for Europe, you see that there's 20 plus that is announced now as being coming online by 2023 and onwards. So it's a huge supply that's coming up. However, if you look at this, that most of these are aiming towards the automotive industry. So what I also expect when it comes to new players here is that there will be room for smaller battery manufacturer that is actually addressing the stationary side. And the reason for this is that generally you have a better margin on if you're providing batteries towards stationary stores. Not so big contracts, and generally the automotive, the OEMs are much better at negotiating the prices for their suppliers. So I think that is also an area where you see that you will have a new entrants coming in. So yeah, I think I stopped there because we are moving in time. I think we should perhaps try to let some of the audience questions be answered as well. And maybe Ismail is back with better
for sure.
audio.
Yeah, thank you, Johan. Ismail, I'm not sure if you can speak in better conditions.
I can try. Let me know if it's.
At least we are listening to you.
Sorry about that, but it's the world we live in nowadays.
Of course.
Internet issues. Just a brief comment on that topic, because we are working on let's say to addressing this problem two ways. So one of the things is, of course, for charging stations, the impact that it has on the grid infrastructure, and if it's not properly managed, the peak power demand. And we are working these two ways. So for fast charging stations that can have integrated on the charging station itself a battery system that can smooth the impact directly on the charger on the grid, so that you can manage the charging and the ultra fast charging in a better way. And another way to do this is when you have multiple fast charging stations or ultra fast charging stations, and it is a trend to increase the power on the charging stations, and it will continue to go up, not only for light vehicles, but when we are talking about heavy duty vehicles, for sure, the charging stations will be massive and their impacts will be large. So, and for this, we also design, so our R&D and our engineering design a battery system that can cope with and act as a buffer for multiple charging stations. And on top of this, an integrated management system that can provide smart charging and also use the battery system so that any of the grid constraints and the grid impacts are minimized. So I think that there is an opportunity as well in this part for, let's say, the stationary application. Of course, they will be strongly coupled, and as Johan was commenting, there will be as well an opportunity, for instance, in charging stations to use second life batteries from EVs, for instance, to do this kind of services as well. So I think that this will come as well in the industry in the future, because not only Europe will need to to go for more production capacity, accompanied by more and more recycling capacity, but also the second use of these energy storage systems will be, I think, very important in the future for us to mitigate the overall impacts in a life cycle perspective. So that would be my generic comment on this. So, but I agree with you. We should go to the questions.
Yeah, for sure. And well, reuse the batteries from the automotive industry is also aligned with some of the comments the audience have been sharing in the Q&A section. So I'll guess, and thank you, Ismael. I'll guess now it's time to extend the discussion and bring some questions from our audience. We'll try to post them to you. So feel free to reply or add any additional comment on your own replies. So one of the questions that I checked, and it's also interesting, is related with if we are seeing long duration energy storage as a game changer, considering the high penetration of renewables in Europe, or will energy storage limited to short duration periods? So I guess you can address this question. Is an interesting one. So feel free to.
I cannot. Sorry.
Okay.
Can I just go ahead, because I think we have heard some of the answers to this already. I mean, there's been a huge focus on, at least on new storage and battery storage, a huge focus on lithium-ion batteries. But in all installations we see in that, even the really big ones that are we see in Australia or US, they are up to 4 hours. That's sort of where you end up with an optimum on that, a little bit depending on the market, of course. But I would suspect that 4 hour plus storage on battery side is also going to be interesting. And I would expect specifically then in conjunction with renewable parks of wind or solar or something like that. And then I think there is a good opportunity actually for flow batteries. And there's a lot of again, we see a lot of activity on smaller companies that are trying to launch that. But also there is a big interest actually if you speak to companies like Vestas or Siemens Gamesa and these that are actually looking at possibilities for energy storage in this respect. So.
Okay, thank you, Johan. I'm not sure if someone else wants to comment on this topic.
I can just make a brief comment on this. At least my perspective from the market, we first had battery energy storage systems mainly providing, let's say, ancillary services with very short durations, so 30 minutes, 45 minutes of discharge duration. And we are now seeing a trend for longer discharge duration. So nowadays you see more and more applications on 2 hours, 4 hours even, that are based on lithium-ion batteries. But I think that the 4 hour let's say frame is where other technologies can start being more competitive, especially if you look at the levelized cost of energy, or if you look at the total cost of ownership of the system. And I think that for sure other technologies will start to come up when as the market goes for longer duration systems.
Eduardo, now you're mute.
I'm sorry. Yeah, thank you, Ismael. Well, we have some more questions. Part of the audience want to know what's your perspective on when comparing hydrogen storage versus battery storage.
Perhaps I can take that one.
Yeah, Mario.
I didn't reply the first one.
Yeah, go for it.
Very personal opinion. I mean, I worked with hydrogen 10 years ago now, then went to batteries. I mean, when we think about power to gas to power, probably we are still talking in a very long future for those applications to be let's say, to have a kind of economic interest, because the efficiency is very low. But I think for the short-term storage, chemical storage in batteries or other mechanical storage are more ready technologies with a very high deployment of renewables and high curtailment times. Probably there will be room for even power to gas to power involving hydrogen for long duration storage or seasonal storage. But I would say this is something to think about in a decade or so.
Can I have a comment on that as well?
Yeah, of course, Johan.
Thank you. Hydrogen is quite interesting, of course, and it's really hyped right now. So it's lots of discussion on it. And again, it's very dependent on the market you are you're active on. If you already have storage facilities in the market or not. And I'm thinking about the Nordic situation where you have a huge amount of hydropower, for example, that can be used. But we also see that hydrogen can be used for storage in another way, and this is actually where I think it really fits, and that's for decarbonizing industrial processes that would be very hard to get at in other ways. And one case that we are looking at and that's being soon demonstrated is to direct reduction of steel. And the thinking there is that, well, shortly it's when you use hydrogen to reduce the oxygen out of the iron ore instead of coal. And what we see is that instead of storing hydrogen in gas form or in liquid form, in other form, you can actually absorb the excess generation that you might have from renewables into the process of actually making iron ore or making the iron from the ore. So there's quite a far gone thinking on actually how to store the intermediate product when you have an excess of renewables in the system. So that's one way of storing actually, which is quite interesting, I think. And then you're not hampered by the situation where you're actually going power to gas to power, because you're not losing out in the second step there of efficiency. So.
Yeah, thank you, Johan. Well, I was noticing as well another question here about future services for the SCOs. So, and also regarding grid scale, but also of grid applications, and considering that battery energy storage is a key enabling technology to promote individual and collective self-consumption and renewable energy communities, and these are already framed, for example, in the Portuguese legislation. So regarding the use that the SCO can make of these assets, the question is if we can foresee that the feasibility of many small scale batteries that are grouped together, maybe as part of an energy community, to provide flexible services. What is your view on this topic? Mario, maybe if since it is related with the DSO use and the benefits coming from managing or at least using a commune asset, maybe you can address it.
Yeah, I mean, like Johan said in the beginning, the regulation for the DSO usage is still, let's say, written clear, but using those behind the meter devices for flexibility, it's actually happening at the moment in certain countries. So it's not future, it's a reality. The way you operate them or you extract value from them, it's also up to creativity. there is a way of doing it today. Probably it's not the same of that will be in the future, but my answer would be it's possible today in more advanced regulation, advanced regions, but in the end probably it will level out. The way we extract value out of it will probably change, but definitely there is a very interesting resource for providing flexibility to the grid.
Yeah, well, I guess that it is a matter as well of having the right business context to foster the use of these assets. Yeah, thank you, Mario. Not sure if someone else.
I can have a comment on that as well, a very quick one, and I just want to second what Mario is saying, because it's even though it's a quite crude way, but it's not uncommon. It's quite common actually that you have batteries to cut the peaks of your power contract with the DSO, and I mean essentially that is positive for the DSO. But I mean it's based on that you have in best cases an hourly agreement with them. So, but still, it's for bigger consumers. This is when you talk about the industries and smaller industries. This is quite common actually. So.
Exactly.
Yep. Thank you. Well, another question. Well, maybe Ismail, you can address this one. So, considering the increasing way of the EVs, we already mentioned this. How do you see the intelligent management of these assets to serve grid integration and other purposes, comparing with the development and with the investment on dedicated grid battery energy storage systems?
I think that for time being they are not competing with each other, but I think they will be rather complementary from one another, and they will coexist in the sense that batteries for sure will have and dedicated systems will have their role once the revenue streams are more clear and we can define them from the beginning, as Mario was commenting. But we today we work with what we have, and we have some perspectives on the future. But going to the kind of, let's say, flexibility that also charging stations can provide when charging vehicles, I think that when that comes, there is a first level of flexibility, so to reduce the demand from the car, and maybe in the future that can be a second level of flexibility if we go for V2G applications, or if that comes online in a massive way in the future. So these are the two levels that I see that can, let's say, somehow offset the need for dedicated and centralized battery energy storage systems. But I think that both will for sure coexist, and if you compare the degrees of flexibility, I would say that dedicated systems can be more flexible and can provide and stack services as we discussed. But for sure there will be and the need when we manage the grid and we perform the energy management of the grid, we need to optimize both, because the way we use one or the other will have a business case behind it. So we need to at all times optimize, not only from the grid and technical perspective, but also from what makes more sense in terms of costs and the economics.
Okay, thank you. I guess we are almost concluding our session. I'm not sure if we have some additional time to a couple of questions more. We have a lot of questions in the Q&A section on the DSO and TSO perspectives. It's normal since we have a huge group in the audience coming from inside EDP. So another question here in the chat mentions that if EDP and FASEC plan to position themselves within the battery market within the battery market value chain in a different position, is named mainly or only as a battery end user and retailer, or will also entering in manufacturing and recycling batteries to generate other business approaches? Mario, Ismael, this one is for you.
Ismael, go first.
I can go first on this one. Of course, things change a lot these days, so I won't provide a definite answer on that. But our perspective today is to be a system integrator with strong partnerships on the battery side, because we need those to optimize the systems and design of our systems and the engineering of our systems, and that's the path that we have followed. And the same will happen for not for recycling, but as we mentioned before, the second life use of batteries. We intend to have that and have a strong positioning on that. But to be honest, I don't believe that we have the ambition to manufacture batteries or to recycle them. We will take care of the cycle life in terms of the operation of the system and getting the most out of the batteries, but not on manufacturing or recycling. Mario.
Thank you, Ismael.
Yeah, I have a quick take on that. Is basically EDP typically provides services and owns assets to provide services, if I'm correct. So nobody can predict the future, but what we can do is trying to address the new technologies and to understand them the best way to provide the best business proposition we can. So at the moment, we are evaluating storage technologies to provide services to the grid, and this is where we are. So I think it's regarding our past, probably is me making a step too far, going too deep into the tiers of not make the technology, but definitely this is a new technology with a lot of steps in the middle. We need to understand them the best way possible, collaborate with other stakeholders, including the two here today, and that's the way to understand this particular technology the best way possible to provide the best business proposition.
Well, thank you. Maybe Johan, you can give us your feedback, and also considering that energy is focused on several thematic fields, but regarding energy storage, can you give us a general perspective on the type of work you are developing in terms of business creation and project support?
Yes, absolutely. I mean, we are first of all we look upon specifically on the battery value chain from a more systemic perspective, because we consider ourselves to be part of an actor that is really promoting this in Europe. So we have been very deeply involved in the battery strategy on European level. We have been supporting in writing that, or we have actually written it. And we have done the same for a national battery strategy in Sweden, and we're doing exactly the same thing for a strategy in Hungary now. So on a systemic perspective, we're deeply involved in that. We also then are running something called the European Battery Alliance, which is promoting industrial efforts or startups in all the different parts of the value chain. So example of this is that we try to promote establishment of raw materials supply in Europe. So right now we are supporting 4 mining establishments that are trying to get into the lithium mining and refinement in Spain and Portugal and Germany. We also support battery manufacturing startups there. Northvolt, it's one of the first one in Europe that's going to come online. We were actually the first one to invest in those guys. We have another in France that we are trying to start up now in order to make sure that there is a full supply of battery cells that is satisfying the market in Europe. So these are the bigger efforts that we are doing. We also, of course, are looking at the next generation of chemistries. We are looking at different efforts when it comes to recycling, for example, very important. Not really because will be a large stream of EV batteries coming back, but as soon as any of these big manufacturing comes online, they have about 10% scrappage of cells, which means that they need to recycle that immediately. So it's going to be a very, very big business. So we are actually active in most of these cases, and investing in some cases, supporting in getting financing in others, and supporting in connecting the different players in the value chain in other cases.
Okay, thank you. Well, we are at the time. Thank you so much, Mario, Ismael, and Johan. I guess that we had your own perspectives and your organization's perspectives as well. It was a pleasure. Thank you.
Thank you.
My colleague, you're welcome.
Thank you.
My colleague, Alexandre Neto, will now close the session. Thank you to our audience as well. We hope you enjoyed. See you soon. Goodbye.
Bye.
Goodbye.
Thank you very much, Eduardo, and thank you to our speakers, Ismael, Mario, and Johan. And thank you to the audience. I guess this was a very interesting discussion about a very exciting subject and technology. We will be following the development of these technologies, and namely the impact of the mobility on the technologies, the evolution of the business cases. I think this is still very exciting, but we are already seeing a lot of applications today from batteries, and they will continue to increase its share and its participation in the energy sector. So this was great. Thank you again to all, and see you next time. I guess in March we'll have another session with a different subject, and see you there. Bye bye.